Okay, welcome everyone to our presentation about web-based modeling tools and building them with Eclipse Theia and Eclipse Che. I would like to introduce my dear colleague Philip. He has helped me with preparing the slides and the demo, and I have the honor to present those awesome slides now. So let's just dive right into it. Why would you even bother building web-based tools? I see three main advantages. Accessibility. So once you have a web-based tool, you don't have a client installation anymore. You can just provide people with a link and they can connect to your modeling tool. They have your modeling environment and they can, without any kind of installation, do whatever they need to do there. There's simple client updates, namely just refreshing the browser, so you don't have the hassle anymore to bring the modeling environment to the current state. And also something, if you have a little bit more complicated modeling tools, where you, for example, have a quite resource-hungry analysis or simulation component, you don't require people to have good laptops to be able to run this analysis in an efficient way anymore. You can just share those resources once it runs on a backend. Then, of course, usability. So you get a modern UI look and feel with a web-based tooling. You don't deal with SWT anymore. You deal with HTML5, no GAF, but SVG. And finally, maintainability. I think on the long run, if you look at it, there is more room for evolution on web-based components. There's just much more people that work on those kinds of components. And you will, if you think about it from a more project managerial point of view, probably it will be simpler for you to find developers that can help you to maintain and develop those tools. Now, once you've decided to go there for whatever reason, what do I actually mean by a modeling tool or tool? This is a collection of what I've seen over the years. Our business is developing modeling tools at Eclipse Source and tools. Sometimes I leave out modeling because some people don't realize that it's, from my perspective, a modeling tool. And for those tools, there's a set of typical features that always occur there regardless of the domain. So be it in the financial domain or automotive, there's a couple of features that always needs to be there. First one is there needs to be some kind of a workbench. So you need to have some window arrangement. You need to be able to have a menu. Often you have an Explorer component to be able to browse some kind of a file system or hierarchy. And then within that workbench, you will have editors. In many modeling tools, you have form-based editors that allow you to, maybe with a tree or without a tree, select an element and then edit the properties of a certain element of your model. Then many times you have diagrams, because for certain types of modeling, it just makes more sense to display that in a diagram. Often for behavioral models, you have diagrams to be able to visualize those. Still, you also have text in those modeling environments, so you can have textual modeling, or often enough you just generate code from the models. Then you maybe want to be able to edit that code in the environment. You might have some analysis or simulation components to visualize results that you obtained from the models, because you don't just do the models for the purpose of having them. And then often generators, so model-to-text transformations where you generate source code or other textual artifacts from your model. And this is kind of what I would consider a prototypical modeling tool. And in the remainder of our presentation, we will try to show you how to develop such a modeling tool in a web-based way. Why am I giving this presentation now? Was that not possible 10 years ago? Yes, it would have been possible, but at a much higher cost. And I think since the last 2 years, there's a number of key enablers that make it possible to build those modeling tools in a much more effective, cost-effective manner. First one being Eclipse Theia, which is an extensible cloud IDE. If you use that for a basis, you get a lot of things for free. And it's the default front end for Eclipse Che, which is just right away the next technology that I see as a key enabler, which is a Kubernetes native IDE platform. It allows you to manage workspaces for multiple users and the development environments for those users. One development environment could be the modeling tool. And finally, something that's maybe not visible on the surface, but that just enabled that in the back is the language server protocol. With the language server protocol and the client implementation, it's possible to get textual support for many languages out of the box for Eclipse Theia and also for other platforms. And the idea of the language server protocol in a nutshell is that you separate out the language smarts of a particular language into a server component, and then you only need a generic client component that is able to provide the user with code editing, but that doesn't understand anymore how the language actually works. And that backend that you implement can then be reused on multiple platforms. And this approach is broadly adopted. So VS Code also uses that. So I think that's the way to go forward if we speak about textual modeling. And it's a good design pattern overall. If you're interested in an introduction to Eclipse Theia and Che and in how Eclipse Theia and Che can serve you with features just out of the box, there's another talk today at 5, also in the same room. So we want to do a web-based tool, a modeling tool. We've defined what it is. It seems to be possible, hopefully, but do we now need to, if we already have a modeling tool, do we now need to reinvent the wheel? And which components can we actually reuse? What do we need to rewrite? And how do we separate in this new situation between front-end and back-end? And to elaborate on that, I just would like to pull out one very particular example. So let's assume you have a modeling tool and you want to reuse a code generator that you had written for your desktop-based modeling tool, and you would now like to reuse it in a scenario where you employ a web-based solution based on Eclipse Theia. Before we dive into the example itself, we need to take a look how Eclipse Theia is architectured on a very high level. So you have an Eclipse Theia front-end component in blue. This runs in the browser and supplies you with the user interface. So you have views, you have menus, you have this Explorer view that I mentioned earlier, all those kinds of things. And it's based on JavaScript, TypeScript. And then you have a Theia backend. And in the Theia backend, this runs on the Node.js server, also JavaScript, TypeScript. And in the Theia backend, you can do other things like, for example, connecting to services that don't run within the Node service and supply additional functionality. Eclipse Theia is extensible, as I said earlier. Actually, all the features that are in here in Eclipse Theia are built anyway with the extension mechanism they supply. And there is front-end extensions and back-end extensions, and they contribute to the front-end or to the back-end. Now to the example at hand. We have the Eclipse Theia front-end and back-end, and we have our code generator, which is the existing piece of code that we already own from our desktop-based tool. This code generator in this particular example runs on Java, so it runs in the JVM. And the first thing that I need to do is I need to somehow, it's visualized by the yellow border, I need to somehow make it accessible to be able to launch this code generator from my Node.js server. So in the simplest case, that would be just adding a main method and adding a parameter with a URL where to generate the code to, and we would be done. And then I would add a backend extension, which basically just launches the generator. So I call that generator launcher. And it needs, from Node.js, it needs to launch Java on the command line, pass in as a parameter the current Theia workspace location, and then the code generator would just dump its code there. Now the user needs to be able to trigger that somehow. The first increment that you could do is just add a menu contribution on your model file, generate code. This model contribution would then call the generator launcher in the backend, and it would launch the code generator. So that shows, as a very simple example, how you can reuse stuff. Actually, I think it's representative for many functionalities of this kind. And the code that you need for that is quite minimal. Most of the code will be in the code generator, and you will reuse it. You need to add a little bit of code to the code generator to be able to call it from outside. And this launcher and generator UI are really a couple of lines of code. Okay, now reuse is possible, but how does the overall tool architecture look like with regard to the front end? Because obviously for the front end, if you had built, for example, an SWT-based tool, you cannot just reuse that entirely. So for the front end, we have different editors that are depicted here on this screenshot. I have a Formbased editor here, I have a graphical editor over there, and I have a textual editor here. They are built with different technologies, but all of them need to somehow be able to get their data. And in this architecture that we propose in this talk, they are using a component called the ModelServer, and it's in the component of the Eclipse EMF.cloud project. The idea, I will later on go into details on the ModelServer, but the general idea is that you somehow need to be able to retrieve the part of the model that you're interested in as an editor, and that you need to be able to subscribe to updates of that part of the model so that you can refresh whatever you display. So for example, the graphical editor needs to refresh the name of a node in case it updates. The remainder of my talk will be demo. I will demo a modeling tool for a coffee maker, for the sake of an example. So this model will structurally model the coffee maker, consists of a dip tray, a control unit, a brewing unit, a tank, and the like, and a behavioral model to describe what the coffee maker is supposed to do. So that's an activity diagram, basically. And then we have a couple of features in the example IDEs to be able to do that. We will have a tree editor to edit the structure of that coffee maker in a form-based way. We have a graphical editor to add the activities of the coffee machine. We have code generation, so we will generate some code from that model for the activities. We will then look at how to edit that Java code in this web IDE and to debug it. We will also have a textual modeling component to add some textual model. Finally, a model analysis component to visualize a certain analysis based on the model, and in the end, multi-user support. So how do I now take this IDE and supply a workspace to a user where they can work in an isolated way? Let's start with the form-based editing. For every demo step, I will first demo the functionality, and then I will go back to the slides and explain how we have done that. So on this console, I will launch Theia and open it up in the browser. And here I have this Explorer view that we talked about, and I have files here, and I have one file that describes my coffee maker model. I can just open it up by double-clicking. And then I get to a form-based editor with a tree. I can add components to the tree. So I could, for example, add a dip tray in here, and it shows up. And then depending on the kind of component, there's other things I can add inside. So for this one, I can add a control unit, for example. When I select something in the tree, it opens up in a detail view, and I can start editing the different attributes that are in there. And I can obviously also select existing elements, and it'll bring up a form that corresponds to a certain type of element that I've selected there. So how does that work? The tree itself is implemented based on the Theia tree widget. That's the widget that's also being used for the Explorer view that you can see there. And if you want to do such a tree, basically you need to provide something like a label and a content provider, if you're familiar with EMF. So something that defines the labels for a certain type of element and the children for a certain type of element. The detail form itself that you saw on the right-hand side when a node is selected is based on JSON forms. That's a declarative approach, so it was not programmed in HTML5, this form, but a JSON schema was created that describes the data, and an artifact that's called a UI schema that describes the form. And based on that, the detail was rendered. For the synchronization, we applied the EMF.cloud model server and used its TypeScript-based model ModelServer client API. So this ModelServer also comes with different client APIs so that it's simpler to connect to the ModelServer. If we look, and basically what it does is whenever I change something, so I type something into one of the fields, it pushes a command to the ModelServer to update the state on the ModelServer, and it can subscribe to updates, which we will see later on in the demo. From an architectural point of view, coming back to the architecture diagram of earlier, we have the front end and the back end of Theia. So what did we need to do in terms of components to get this running? Well, we need the editor itself. The editor is a front end contribution. What it does is basically tell Theia that it wants to be responsible for .coffee files, and then it needs to contain the implementation for the editor itself that is able to visualize that. Then in the Theia backend, we contributed a model connector that allows this tree editor to connect to the ModelServer. So this model connector takes care of establishing a connection to the ModelServer for this particular model and for subscribing to updates. If you're interested in more details on how JSON form works, there's a talk about property editors in space. It also involves some neat AR demonstration, and it's on Thursday, 1 p.m. By the way, all the slides are already online now, so if you want to look up stuff that I've now written down as recommendations, you can just do at this moment already. Graphical modeling. So let's look into graphical modeling and how that is realized in this demo. So what you can do in this demo is you can select this workflow here and open it as a diagram, as a workflow diagram. And then you get this diagrammatic view of the workflow. So this displays the different activities that users may perform, like checking water, and then there's the decision nodes and the like. And of course, you can also just edit stuff here. So you could, for example, add a manual task that every time you drank a coffee, you need to curse. Okay, that was in the wrong direction. And otherwise, you can zoom and add nodes as you like. And this is this whole thing is based on GLSP, the Graphical Language Server Platform. The idea of GLSP is the same as LSP, but for graphical editors. So you will have a GLSP client, which is largely generic, and it displays a graphical representation of a model. And you will have a GLSP server, and that server contains the language smart. So it knows how to map the different activities, in this case, of a coffee maker onto a diagram specific to a certain DSL. And it also contains the synchronization with the ModelServer. The Graphical Language Server Platform is based on another Eclipse project, which is about graphical visualization, and it's called Eclipse Prati. If we look at that from a component point of view, we contribute to the front end, the GLSP editor. It's a blue component because it's largely unchanged. There's a little bit of a yellow custom implementation that is for the shapes. So for every element you have on the diagram, you need to define its shape, for example, in terms of an SVG. Then you need a connector that's a backend contribution that is more special because it needs to know, for example, the file extension of the diagram files that you're visualizing. And this one also connects to the DSL-specific GLSP server. The GLSP server can use components from GLSP core to fulfill its duty, but more importantly, connects to the ModelServer. So if you think about it now, it needs to look at the different activities that are there, read them in. It needs to see whether an activity is connected to another activity. If that is the case, it needs to tell the client to draw an edge, for example. So this is the activity that the GLSP server really does. And whenever something on a diagram changes, it also needs to propagate those changes back. So let's say a user clicks on which is actually something I did before. I named the node. So if you name the node, then the GLSP server is the component that knows that this name is the name of an activity, of the corresponding activity, and it writes it back into the original model. If you're interested in that particular technology, so diagrams with GLSP, there's a talk on that on Thursday. And it goes into the technical details, how it actually works. Now the model server itself, we've talked about that a lot already. So those are not just two editors that just stand side by side. Those two editors are actually connected. So if I want to be politically more correct and change that into complain, and it also updates in the tree-based editor. And if I also wanted to write it correctly and change it here, it also reflects on the other side in the node. So what happens here is that those two editors both connect to the model server and to the same model resource, and whenever one side changes something, it's pushed to the other side. How does that look like in detail? So if you think about it, on the right-hand side, we see what I would say is the one connected graph that makes up the model of that coffee maker. And in that graph, there's certain parts that are visualized by certain editors. So only a certain part of the model will be shown in the tree view, the structural part. And only another certain part will be shown maybe in a textual editor and another part in the graphical editor. The first part will be shown in this JSON Forms-based editor, the second one in the GLSP-based, and the third one in a textual editor based on LSP. All of them could just communicate with each other to somehow make sure that they know that this other editor changed something, but of course that doesn't make a whole lot of sense. So the architecture that we already discussed earlier is that all of them connect to the model server. They request the part of the model that they need to display whatever they display. So the graphical editor, for example, will only care about the activity. And then they subscribe to that part of the model. So whenever another editor would change exactly the same part, such as the name of an activity, then this editor would get notified and can update its visual representation. The model server is a component of the Eclipse emf.cloud project, and it features this command-based change interface and a notification mechanism. And there's also some convenient client APIs for Java and for TypeScript to be able to interact with the server from the client side. If you're interested in that, there's also a great talk about it, lifting the greatness of EMF into the cloud with emf.cloud. It's on Wednesday. It will provide technical details how the model server is implemented and how you can use it. Generators. So if you would like to generate some text like source code, that is also integrated here in the demo. I can just right-click this coffee maker file and then generate workflow code from that. And it pops up in my workspace. Here we have a class for the complaint that we modeled earlier, and it contains some generated code. The idea of that generator we discussed earlier already, because it was the example how to reuse something. The generator itself in this case is based on Eclipse Extend. We basically build a jar from the generator, and then we launch it via the command line interface. Basically, we just launch a JVM and pass in the workspace folder as a command, as a parameter. Now that we've generated the source code, it's also interesting to work with that source code. So this editor that I have here is fully functional, if I do it correctly. So you have auto completion in here. And there's also some other features you would expect from a code editor. Welcome to ECE. So for example, if you would select a string, there's also some refactoring options that become available. You could extract that to a constant. And in addition, you can also run and debug that code. So I could just open up a test case that was generated for all this. It's in this class. And set a breakpoint before we run the complaint. And then just launch the debugging for that. So this brings up a debug view with threads and also with the call stack of the currently running thread that stopped at run complaint. And then the usual things like you can step into that and then can step over. Obviously, I will now step down to task do execute and step into pre-execute. And that brings us exactly to the location that I've added the code to. Now if I would step over, we see that we have the output of welcome to ECE. And I'll just continue. Now, working with source code is already also well supported in Theia. The enablers for that are two, the LSP that we talked about earlier already, and the debug adapter protocol. So Theia ships with a code editor that's based on Monaco, which is also the same editor that ships with VS Code. And this editor is LSP enabled. So as soon as you have an LSP server for a particular language, in our case for Java, this editor is able to provide you with syntax highlighting, with auto-completions, with refactorings, and the like. Basically, this editor uses the LSP server to understand the language. And the same or quite similar goes for debugging. There's a Theia debug extension which provides the UI for the debugging, and it uses the debug adapter protocol to support the language-specific debugging steps. If we look at that from a component view, we have the front end and back end. And now we can just use existing components. So we plug in this LSP editor, which ships with Theia edit anyway, connector, and this connector then connects to an existing LSP server implementation for Java. In our case, it's called JDT-LS, the Java Development Tools Language Server. And as the name implies, it uses the Java development tools, just the same Java development tools that run within Eclipse. So if a Java file is parsed, it's exactly the same code that you would run inside Eclipse. Same goes for the debug functionality. There's a UI component that ships with Theia. Then there's a debug adapter protocol connector, and it connects to a server process that runs in a JVM called the Java debug server. It in turn actually even uses JDT-LS because it also needs access to parts of the AST, for example. So working with source code in this environment is like, as long as you have a language where a debug adapter protocol implementation for a server and an LSP server is available, is super simple. And in the end, another JVM will of course launch for the Java program that we had just created and run as a test case. Textual modeling is also, apart from modeling, from running or editing source code, it's often interesting to edit parts of your model in a textual way. We have an example in here. So this is a configuration file for an analysis, and that supports syntax highlighting, for example, and validation. So if I put, I think 1.1, then it tells me that this is a probability, and it can be at most 1. And there's also some assertions that I can make here about activities. So basically I can tell the analysis here that the preheat activity needs to happen before brew, or I could just add yet another activity like drink needs to happen before complain. And these activities are now the same activity that we just added to the model before, because the complain activity was the one that we added. Now for the textual modeling, simple, short story is, there is an LSP for the textual DSL that we have here, so we can just use the Theia editor that ships with Theia. And in the backend, we have a DSL that was modeled as an Xtext grammar. And with Xtext, you get an LSP server for free. You can just generate it. So you have the LSP editor in the front end as a contribution again, the connector, but this time an Xtext-based LSP server. The only thing we actually had to manually implement is a so-called provider for the auto-completions there for Xtext, and it provides the activities. So it needs to go to the ModelServer, read in all the available activities, and provide it to Xtext. Analysis, I promised that earlier. So you can run an analysis from this editor, and you get this D3-based visualization of an analysis of the potential execution paths and their probability. This component has been done with in the front end with D3, which is a really neat visualization library for JavaScript. And in the back end, we need to fetch the data from the model server, and then we need to crunch the numbers on that to come up with this analysis result. So there's a front-end contribution. It's only this menu contribution to be able to run the analysis. And then there's a connector in the backend that launches this analysis service. And since Philip wanted to try Kotlin for a long time, he implemented that in Kotlin, but it runs in a JVM. And then this analysis server connects to the model server to actually fetch the data. Multi-user support. Now that you've created this modeling environment, maybe you want to share it with multiple users and they should have their own workspace. This is Eclipse Che. I would just very briefly dive into here. The only difference that you see now is we have the same modeling environment here with the graphical view and this form-based view, but now we also have workspaces based on Eclipse Che. So basically this now runs within Eclipse Che, and what it means I will explain at least a little bit on the slides. So the idea of Che is that you have a Che server that people can connect to, and this Che server can have a bunch of workspace configurations that are available to the Che server. Now a user can come along and can tell the server to provide a workspace with that particular configuration, and then the Che server will launch that workspace and deploy that workspace configuration there. And one interesting configuration that you could have is a Theia workspace configuration. So a workspace that contains the Theia IDE or this particular coffee editor IDE that we have built. And you can go to the Che server and ask it to deploy a workspace for that. What it means basically is that it will bring up a machine, deploy all the required services there, and provide you with a file system to store your files. I will skip the excursion on Kubernetes. Actually, Che runs on Kubernetes to supply you with those workspaces, but I think we don't have enough time to go into that anymore. And also how Che and Theia work on Kubernetes. Just as a quick wrapper, Kubernetes allows you to have a cluster with multiple nodes that are physical machines or VMs, and it allows you, in combination with Che, to push workspaces to that node. So when a user arrives at the Che server, and they request a workspace for the coffee editor, for example, they Che and Kubernetes in combination take care of provisioning the node with all the required stuff, deploying the Theia IDE that you built there and giving you access to a file system. As a summary, so in my mind, in the recent 2 years, web-based modeling tools have become much more feasible today at a reasonable cost, which was not the case before. In many cases, of course, depending on your use cases, but you've seen that there's really use cases where reuse and migration is easier than expected because you don't need to rewrite a lot of things. And there is some unique advantages that you can leverage by them. So if you want modern UI styling or zero installation for users, or you want to enable a cloud-based business model for yourself, this is the way to go. There is open source components to support you in that process, namely Eclipse Theia and Eclipse Che, but there's also others that I've named throughout the talk to help you in doing so. And also you don't need to throw away your entire tool. You can often enough reuse large parts of the tool. If you like that demo, you just want to get inspired what you could do, the whole code is available open source in this source code repository. And if you really would like to go for a web-based tool, I can only encourage you to think about a strategy and a time plan and build a proof of concept. In my mind, that's really important to find out whether it's feasible and what the potential effort could be. Thank you very much.